Bronsted and Lowry concept of acids and bases. In the previous video, we got acquainted with the concept of Arrhenius, which explains the acid-base behavior of some substances, but as we mentioned earlier, he couldn't explain it to other substances. Also, Arrhenius explains that acid ionization produces a negative ion and positive hydrogen ion. This hydrogen ion is a hydrogen atom that has lost its electron, so it can be considered a proton. It's a very infinitesimal particle with a high electrical density, so it cannot be alone in a solution, but is connected by a coordinate covalent bond with a water molecule, forming the hydronium ion. These points called scientists to search for another concept, as the scientists Bronsted and Lowry came up with a concept for both acids and bases and more comprehensive than the concept of Arrhenius. So let's get acquainted with the Bronsted and Lowry concept of acids and bases. In their definition, Bronsted and Lowry relied on the transfer of hydrogen ion, the proton, between substances during reaction. Bronsted and Lowry defined the acid as a substance, whether molecules or ions, that donates a proton, hydrogen ion, in a reaction. While the base is a substance, whether molecules or ions, that accepts a proton, hydrogen ion, in a reaction. So, this molecule is considered an acid because it's a proton donor, while the second molecule will be considered a base because it's a proton acceptor. For example, when hydrofluoric acid reacts with ammonia, as we see, hydrofluoric acid, according to the definition of Bronsted and Lowry, will donate a proton to the ammonia molecule, producing a positive ammonium ion and a negative fluoride ion. Therefore, HF is considered an acid because it's a proton donor, while the ammonia molecule is considered a base because it's the acceptor of this proton. Let's consider the equation together and observe the change between the reactants and the products. As we can see, hydrofluoric acid is a proton donor, so the number of hydrogen atoms in it will decrease, and fluoride ion will be produced. While ammonia will accept this proton, so the number of hydrogen atoms in it will increase, and the ammonium ion will be produced. So according to the definition of Bronsted and Lowry, the acid is a proton donor. That is, the number of its hydrogen atoms decreases, while the base is a proton acceptor. That is, the number of its hydrogen atom increases. Let us consider together a set of equations to determine the acid and the base according to the definition of Bronsted and Lowry. As we can see, this equation represents the interaction of HCl with water. So first of all, it's necessary to consider the change that occurs between the reactants and the products. As we notice, that HCl is a substance in which the number of its hydrogen atoms decreases, which means it's a proton donor. So according to the concept of Bronsted and Lowry, HCl is the acid in this reaction. While water is a substance in which the number of its hydrogen atoms increases, which means it's a proton acceptor. So according to the concept of Bronsted and Lowry, H2O is the base in this reaction. Another example, and the first step is to consider the equation and observe the changes in it. As we can see, NH3 is the substance in which the number of its hydrogen atoms increases, which means it's a proton acceptor. So NH3 is the base. While water, as we can see, is a substance in which the number of its hydrogen atoms decreases, so water is a proton donor, which means that H2O is the acid in this reaction. After considering this equation, we note that hydrazine is a substance in which the number of its hydrogen atoms increases, so it's a proton acceptor, which means that N2H4 is the base. While water is a substance in which the number of its hydrogen atoms decreases, so water is a proton donor, and that means H2O is the acid in this reaction. In the following example, which represents the reaction of formic acid with water, formic acid is the simplest carboxylic acid. As we can see, formic acid is a substance in which the number of its hydrogen atoms decreases, so it's a proton donor, which means HCOOH is the acid in this reaction. While water is a substance in which the number of its hydrogen atoms increases, so it's a proton acceptor, and that means H2O is the base in this reaction. Another example, after considering this equation, we note that HSO3- ion is a substance in which the number of its hydrogen atoms decreases, so it's the acid in this reaction. While water, as we note, is the base. In the following example, we can see that the CO3- ion is a substance in which the number of its hydrogen atoms increases, so it's a proton acceptor, and that means it's the base in this reaction. While water, as we see, is the acid. Let's consider these two equations together. In general, when Bronsted and Lowry acids react with water, the hydronium ion is produced. Whereas, when the Bronsted and Lowry bases react with water, as we can see, a hydroxide ion is produced. We also note that water may exhibit acidic or basic behavior depending on the substance which it reacts with. Therefore, it's considered an amphoteric substance. In the second part of the concept of Bronsted and Lowry, we will learn about the conjugate pairs of acid and base and find their formula, so be with us. Big thanks for watching. At the end, don't forget to like, share, and subscribe to receive my new videos.